This video is over how to add and subtract while in scientific notation. Now, the easiest way to add and subtract in scientific notation is to make sure that all numbers are written in standard form. There is a way to add and subtract while still in scientific notation, but it is very complex and it is very easy to make really easy, careless mistakes. And so writing all of the numbers in standard form and then just adding the regular numbers is a much easier method. Now, it's important to remember that when you are writing numbers in standard form and we're adding or subtracting, we need to line up the decimal points. We're going to line up the decimal points and then we're going to add the numbers or subtract the numbers. We're going to do 10 examples in this video. In example number 1, we're going to have the equation 6.2 times 10 to the 8th plus 2.3 times 10 to the 7th. So we're going to start with the 6.2. We're going to move the decimal 8 times because that's my exponent. We fill in all those placeholders with zeros, and then we write the answer more clearly. And we end up with 620 million. For 2.3, we're going to move the decimal point 7 times, filling in all those placeholders with zeros. And we rewrite our answer more clearly, and we get 23 million. So when we add them up, we're going to add up the 620 million. And we're going to add it up with the 23 million. Notice how I line up my numbers. My decimal points that are at the back are lined up together. Line up your numbers straight across. And then add. We get zeros across the bottom so far. In the second set, we still get 0 plus 0 to give us 0. In the third set is when we have some actual numbers. 0 plus 3 is 3, 2 plus 2 is 4, and 6 we can bring straight down. 643 million. We're going to take that answer, we're going to rewrite it in scientific notation. So we move the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. And we find our final answer as 6.43 times 10 to the 8th power, because we move the decimal 8 times. For number 2, we have the number 1.9 times 10 to the negative 5th. We're going to add that to 5.42 times 10 to the negative 5th. We start by moving our decimal point to 1.95 times. Because it's negative, we're going to move the decimal towards the front, so the zeros are in the front. 1, 2, 3, 4, 5. We plug in those place values with zeros, and we rewrite our answer. 0.000019. For the second number, we have our 5.42. We're again going to move the decimal point 5 times. Because the exponent is negative, we're going to move the decimal point towards the front, so the zeros are in the front of the number. 1, 2, 3, 4, 5. Again, filling in those placeholders with zeros. And we get 0.000542. Now, when we add those two numbers together, we want to take our numbers, we want to line up the decimal points, and then we can add them together. 2 and nothing, if you want to put another 0 there, you can to fill it in. 2 and nothing is 2. 9 plus 4 is 13, so put down the 3, carry the 1. 5 plus 1 is 6, plus 1 is 7. And then all my zeros added together stay 0. And our decimal point stays out in front. So our answer would be 0.0000732. To write the answer in scientific notation, we move the decimal point back 1, 2, 3, 4, 5 times. And we get our answer of 7.32, always times 10. And it's to the negative 5th power because the zeros are in the front of the number, representing a small number, which is why it is a negative exponent. For number 3, we're going to do the number 9 times 10 to the negative 3rd minus, we're going to do 4 times 10 to the negative 3rd. We're going to start by moving our decimal point. In our whole number 9, our decimal point is behind the number. We're going to move it 3 times, and we're going to move it towards the front, so the zeros go in front of the number because it's a negative exponent. 1, 2, 3. We fill in those missing values with zeros. We're going to do the same thing with our 4. Our decimal point starts off behind it. We're going to move it 3 times, and we're going to move the decimal point towards the front because the negative exponent is representative of zeros in the front. So that's 1, 2, 3. We're going to take our new numbers and we're going to subtract them. So 0.009 minus 0.004. Notice we line up those decimal points. 9 minus 4 is going to give us 5. 0 and 0 are still 0. And our decimal point comes straight down. We want to write the answer in scientific notation, so we move the decimal point 1, 2, 3 times. And so our answer becomes 5 times 10 to the negative 3rd power. It's a negative 3 because the zeros in the front are representative of a small number, so we use negative exponents. For number 4, we're going to do the problem 4.7 times 10 to the 7th power plus 3.4 times 10 to the 6th power. We're going to start by moving our decimal point, and for the 4.7, we're going to move the decimal 7 times. So that's 1, 2, 3, 4, 5, 6, 7. We're going to fill in all of those placeholders with a 0, and we rewrite our answer more clearly to get 47 million. For the 3.4 number, we're going to move the decimal 6 times. 1, 2, 3, 4, 5, 6. Filling in those place values with zeros. And rewriting the answer more clearly. And we get 3,400,000. When it comes time to actually add those together, we're going to line up our numbers. Notice how we line them up so the zeros match at the ends. All of our zeros, 0 plus zeros, add up to 0. The 7 plus 3 would add up to 10, so put down the 0, carry the 1. And the 1 plus 4 would give us 5. 50 million would be our final answer. We take that answer, we move the decimal point back towards the front, 3, 4, 5, 6, 7 times. And we rewrite our answer in scientific notation. 5, or 5.0, times 10 raised to the 7th power. For number 5, we have the number 9 times 10 to the 5th. And we're going to subtract it from 8 times 10 to the 4th. We're going to start by moving our decimal point with the 9. Remember, the decimal point is behind the number. We move the decimal point 5 times, 1, 2, 3, 4, 5, filling in those place values with zeros, and then rewriting our answer more carefully and more clearly to get 900,000. For 8, we're going to take our decimal point and we're going to move it 4 times, filling in those place values with zeros, and writing our answer more clearly, 80,000. Now, when it comes to actually subtracting, we're going to line up our numbers. Notice how my zeros line up across the bottom. 0 minus 0 stays 0. But when we come to 8 minus 0, we cannot solve 8 minus 0. We have to borrow. The 9, we borrow 1, so it becomes an 8. The 0 becomes a 10. 10 minus 8 is 2, and 8 can come straight down. 820,000 would be our final answer. We want to take that answer. We want to move the decimal point back towards the front 1, 2, 3, 4, 5 times. And so our final answer becomes 8.2, always times 10, and that's towards the 5th power. For problem number 6, we have the number 2.8 times 10 to the negative 5th. And we're going to subtract that from 5.4 times 10 to the negative 6th. We're going to start with 2.8. We're going to move our decimal 5 times, but because it's negative, we're going to move it towards the front, so the zeros are in the front. 1, 2, 3, 4, 5. Filling in those place values with zeros. And then rewriting our answer more clearly. 0.000028. For our second number, 5.4, we're going to move our decimal point 6 times, but we're going to move it towards the front because it is a negative. We want the zeros in the front. 1, 2, 3, 4, 5, 6. Filling in those place values with zeros. And then writing our answer more clearly. 0.000054. When it comes time to actually subtract our numbers, we're going to line up our decimal points in the front. We can add another placeholder 0 at the back to fill it out evenly. Now, we cannot do 0 minus 4, so we're going to have to borrow. When we borrow the 7, the 8 becomes a 7, and the 0 becomes a 10. 10 minus 4 is going to get us 6. 7 minus 5 gets us 2. 2 minus 0 gets us 2. And subtracting all of our zeros stays 0. Notice our decimal point comes straight down in the line. And then we can write our answer in scientific notation. We move the decimal back towards the first number, which is 5 times. And so our answer becomes 2.26, always times 10, and this would be to the negative 5th power. 5 because we move the decimal 5 times, and negative because the zeros are in the front. For number 7, we're going to have the number 7.2 times 10 to the negative 3rd minus 6.8 times 10 to the negative 4th. We're going to start by writing the 7.2 in standard form by moving the decimal 3 times. We move the decimal 3 times towards the front because it's a negative exponent. Negative exponents have the zeros in the front. And then we write the answer more clearly, 0.0072. For the second number, 6.8, we're going to move the decimal point 4 times. We're going to move it 4 times towards the front, 1, 2, 3, 4, because it's a negative 4. Negative exponents mean the zeros are in the front of the number. And we write the answer more clearly, 0.00068. When it comes time to actually subtract them, we're going to line up our decimal points in a straight line. One of the numbers does stick out the end, so you can put in another 0 as a placeholder. We cannot subtract 0 minus 8, so we're going to have to borrow. The 2 becomes a 1, and the 0 becomes a 10. 10 minus 8 is going to give us 2. We cannot solve 1 minus 6, so we're going to have to borrow again. The 7 becomes a 6, and the 1 becomes an 11. 11 minus 6 is going to give us 5, and 6 minus 0 gives us 6. Our zeros subtract straight down to give us 0. Our answer would be 0.00652. We can move the decimal point back towards the first number 1, 2, 3 times. So we can rewrite our answer in scientific notation. 6.52 would be our number. Always times 10. And it would be to the negative third power because of the zeros in the front. For number 8, we have the number 6.4 times 10 to the 5th. And we're going to add it to 320,000. Now, one of the numbers is already in scientific notation, and one of them is in standard notation. So we do not have to rewrite the 320,000. We only need to rewrite the 6.4, in which case we move the decimal 5 times, filling in those placeholders with zeros, and rewriting our answer more clearly to 640,000. The 320,000 is already ready to be added. So we're going to line up our numbers, starting with our zeros. Notice the zeros in the back form a straight line. Adding zeros, they just stay 0. 4 plus 2 is going to give us 6. 6 plus 3 is going to give us 9, for an answer of 960,000. We want to rewrite that answer in scientific notation, so we move the decimal 1, 2, 3, 4, 5 times back towards the first number. And so our final answer becomes 9.6, always times 10, and it's to the 5th power. For number 9, we have the problem 0.00054. And we're going to subtract that from 3.2 times 10 to the negative 4th. The first number is already in standard form, so we don't have to change that. We will change the 3.2 by moving the decimal point 4 times. We're going to move it 4 times to the front because it's negative. Negative exponents are represented by zeros in the front. And rewrite that answer more clearly, 0.00032. And we're going to subtract that from the original number, 0.00054. We're going to line up our decimal points in a straight line and subtract. 4 minus 2 is going to give us 2. 5 minus 3 is going to give us 2. Our zeros subtract straight down along with our decimal point. We want to rewrite that answer in scientific notation, so we're going to move the decimal point back towards the first number, which is 4 times. And so our answer becomes 2.2, always times 10, and it's to the negative 4th power. 4 because we moved the decimal 4 times, and negative because the zeros are in the front. For our last problem, we're going to have 2.5 times 10 to the negative 2nd, and we're going to add it to 7 times 10 to the negative 2nd. We need to take both numbers and rewrite them in standard form. For the 2.5, we're going to move the decimal 2 times towards the front because negative exponents are represented by zeros in the front. And then we rewrite the answer more clearly, 0.025. For our other number 7, the decimal point starts behind it, but we're going to move it 2 times, again towards the front, because negative exponents are represented by zeros in the front, and we write it more clearly, 0.07. We line up our decimal points, 0.025 and 0.07, and we add them up. 5 and nothing, if you want to fill that in with a 0, you can. 5 and nothing give us 5. 7 and 2 give us 9. zeros added straight down to get 0. 0.095 would be our answer. We're going to move our decimal 2 times to write it in scientific notation. To get a final answer of 9.5, always times 10, and this would be to the negative second power. 2 because we move the decimal 2 times, and negative because it's representative of zeros in the front.